Hey, welcome to 49cc Scoot. My name's Brent. I tested the Stage6 RT-FL100 exhaust on my RC1 a little while ago, and it didn't perform as well as the Malossi exhaust included in the RC1 package. I used the Stage6 Flange, which is round all the way through to match their RT cylinder, but the Malossi MHR Testarossa cylinder has an oval exhaust port, so pairing the two creates a big mismatch. That made me and a lot of you wonder, how much difference would a matched exhaust flange make? So in this video, I'll be building my own matching exhaust flange. Before I get into making a flange, I want to discuss other options as well. Using the Malossi flange would be the easiest option, but it has a larger outside diameter and won't fit in the Stage6 header. My first thought was to buy another Malossi flange and cut down its outside diameter to match up, but this little chunk of steel costs around $100 currently, and not many shops have one in stock. Another option would be to carefully cut off the first segment of the Stage6 pipe that the flange fits into and weld or braze on a larger piece of tubing that will match up to the Malossi flange. That would be the cheapest and easiest option that I think would work well, but I didn't want to modify the exhaust, so that way it could fit the original flange in case I wanted to try the RT100 someday or maybe sell the pipe. Of course, you could switch the header pipe back to the original again, but I would prefer not cutting and welding it repeatedly. The other somewhat obvious choice would be porting the Malossi cylinder to match up to the Stage6 flange. I think that one is the worst option for multiple reasons. You have to be very careful when modifying ports because changing their shape and size can alter port velocity and flow, and you can wind up losing power. The Stage6 flange is a 32mm circle, while Malossi's oval shaped port is about 33.8 by 25.5mm by my measurements. Pi times radius squared tells me that the Stage6 flange entry has an area of about 804.25 square millimeters. Oval ports take a bit more work, so I traced it onto 1mm graph paper and then counted the occupied squares to find that Malossi's port is around 804.5 square millimeters. My method isn't accurate enough to say that they are indeed only a quarter of a square millimeter apart, but it's at least close enough that I don't think the area of the port would be the greatest concern. The problem is, the Malossi port would have to be filled and reworked because it's wider than the Stage6 flange. Filling the exhaust port would not be easy or cheap for me because I can't weld aluminum, plus I'd be concerned that welding could create a risk of warping or otherwise altering the cylinder, or possibly even affecting the plating. I wouldn't expect fillers, like the ones I've used in cooler areas of engine cases many times before, to hold up to the heat and the stress of the exhaust port. In addition, once the port is changed, it's not going to match up with the Malossi flange anymore, so switching back would require more work. The Stage6 flange could be welded to fill the roof and floor areas, and then ported to match the MHR cylinder, but the flange would also have to be cut flat again after welding, and I'd still have a flange that only allows 2 of 4 bolt holes to align with a Malossi cylinder, and I'd have to replace it if I ever got the Stage6 cylinder. Flange building is time-consuming and difficult enough that it's not for everyone, but I chose to take this route because it makes switching between the pipes simple, lets me use all 4 bolts, and doesn't require modification to any other parts that's tough to reverse. Plus, I wanted to take on the project because I knew it would be a challenge since I'm not a pro fabricator or machinist by any means, and I find it rewarding when I can successfully create things. Alright, so the first step was to get materials. I picked up a 3x6 inch piece of 3/16 of an inch thick low carbon steel bar and a 6-inch chunk of 1.5 inch diameter 4140 steel rod, which came out to $43 with tax and shipping, but also left me with material to spare for future projects or if I mess something up along the way. I started by tracing the Malossi flange onto the steel bar. I mainly wanted to get the outside shape for now, but marked the port as well just in case it was useful later. Then I used transfer punches to mark the bolt holes and the holes for the springs that pull the pipe against the flange. The standard punches that I have left wiggle room in the bolt holes, which is not ideal, and it would probably be best to get one that fit well or to use a collar of some sort because the hole location may also affect centering for drilling the large center hole later. I was careful when drilling the bolt holes, but I still wound up needing to elongate one of them a little bit with a burr to get it to match up, which I think is mostly due to the improper fit of the transfer punch when marking. Then I wanted to drill a hole at the center for the pipe to fit into, and at that point I realized that I had made a mistake. The pipe and port is pretty well centered within the 4 bolt holes in the flange, so I should have connected the holes diagonally and drilled where the lines intersected. With the holes already drilled and one elongated a little, I chose to use the port marking to find what I hoped to be the center. I measured the port outline and cut the measurements in half, then set my calipers at each measurement to create a cross that showed the center, and then punched that. I double-checked by measuring the distance from my punch mark to the edges to be sure that they were even. I drilled the flange to 6 millimeters, and then center drilled the rod that I'd use to make the pipe section later, and mounted it before I went any further, so I could see if it appeared to be centered when I bolted it together. Now, I didn't film any of that, because initially I was thinking that I probably wouldn't go over the flange making in any detail. While not expecting it to be perfect, the hole appeared to be close enough to center that I started working my way through with a step drill because it was the only thing that I had to make a large enough hole. Step drills aren't exactly the preferred choice for thick steel, but they work. I did wind up spending another $10 on a cheap bit that went up to 1 3/8", which is about 35 millimeters. I needed to cut the rod to 36.8 millimeters to match the RC header, but I didn't want to drill the hole in the flange all the way to that size, even if I could have, because I planned to hand finish the hole, which would let me make some small adjustments if I needed to get the pipe centered in the flange. I cut off a piece of the 1.5" steel rod, leaving it a little longer than I needed so I could face it off and still have a little margin for error. Here I'm cutting the outside diameter down, and you can see that it was already faced off and center drilled. Again, that was done earlier to look at centering within the flange. I made sure the piece was a snug fit in the header. Then I started drilling and boring the center up to near the smallest dimension of the oval port. The port was basically 1 inch tall in the center, so I bored until the rod was just a little bit shy of 1 inch. Once again, I wanted to leave room for adjustment later. It will require a little bit more time with a carbide burr than if I had took it out right to the edge, but I've got plenty of room to move the port around a little bit if I need to. I also cut a short portion of one end to near the inside diameter needed to match the header, again leaving a little room for blending and smoothing later. I pretty much randomly cut steps into that end so that I'd have less steel to grind away when I was ready to port match and blend eventually. Then I decided that I wanted to put a small O-ring groove on the outside of the rod, so maybe I could use an O-ring to better seal in the oil residue that goes everywhere without one. The Stage 6 flange doesn't use an O-ring there like the Malossi flange does, probably because the Stage 6 flange is thinner and cutting much of a groove would weaken it to some degree. I just barely cut a groove in there about 1/2 millimeter deep and 1.5 millimeters wide, hoping that maybe I could use a 1 or 1.5 millimeter O-ring. It's not a proper O-ring groove for sure, but I didn't want to risk leaving the pipe too thin, and that's about as much depth as I thought I could get away with. With all of the lathe work finished on the pipe section, which I also cut to the intended length to match the Stage 6 flange and beveled on the end facing the cylinder, I went back to working on the flange. I spent some time getting the pipe to sit as centered as I could get it in the flange and marked around its edges, using that mark to help me enlarge the hole. I used a carbide burr to remove most of the material and then switched up to a flap wheel that just barely fit to finish it off and keep the hole more concentric and smooth. Then I went over it with sanding drums to knock off the sharp edges and to create a bevel where the flange would meet up with the pipe. The bevel on the pipe and the flange meet up to give me a good spot to weld the two together. I needed to find a way to hold the two parts together as flat as I could for welding, so I clamped them both to a large chunk of aluminum that I checked for flatness beforehand. I had an aluminum plug around that I made for an engine case that just happened to fit perfectly in the stepped end of the pipe, so I could clamp it down securely with less worry of putting too much pressure on any one area to make it sit crooked. I put the aluminum block in a vise and made 2 small welds that I figured would be just enough to keep the part secure before checking to make sure that the join parts were indeed flat. Then I started welding all the way around the top or the cylinder side of the flange. This was the part that made me the most nervous in the entire process because I don't do a lot of TIG welding and some things that I've done turned out quite poorly, But somehow I managed to make a bead around the entire circumference of the pipe that appeared to have good penetration without mounds of excess material sitting above the surface. I was originally planning to only use the top weld, but after seeing it come out well and putting more thought into it, I decided that it would be better to reinforce the part by welding all the way around the underside of the flange as well. Now I needed to cut the face of the flange flat and trim a little bit of the weld on the underside to give the mounting bolts adequate clearance and a flat surface. But first I had to set the part up as true as I could in the lathe. This is something that I haven't mentioned before in this video, but for anyone that hasn't used the lathe before, this is part of the process all along the way to ensure that the parts end up straight and true. In this case, I got it down to about a 0.5 of an inch of runout, and that's as good as I could get it with any amount of tinkering. I cut for clearance behind the flange first. Then I started facing off the cylinder side of the flange to remove excess weld and try to create a surface that was flat. Once again, I was surprised to see that my weld turned out to be solid. I was expecting to have to go back and do another pass because of porosity and voids from lack of TIG talent, but it actually looked good. I also needed to cut an O-ring groove in the flange, and rather than going through some complex method to get the cutting diameter just right, I decided to weaponize a permanent marker. I clamped the marker into the tool post and set it up roughly where I thought it would be to make a mark with a 38mm inside diameter, but left it a little further toward the outside. Then I moved the marker in very slowly until I measured a 38mm inside diameter. That gave me an alignment point so I could use a 2mm wide grooving tool to cut a 38mm O-ring groove. Next up, I needed to match the flange to the cylinder. There are plenty of ways to go about this, but I chose to put a couple of layers of masking tape on the flange and bolt it on. After tightening, it can be removed and the outline of the port and the O-ring groove can be easily seen. When examining the part, I noticed that the port was not centered within the O-ring groove. It looked like I'd need to move the flange over about 0.6mm to center everything and give even clearance between the port edges and the O-ring groove, so I ground the bolt holes as needed. It may not have been perfectly centered, but definitely close enough. I cut along the port outline and then colored all around the leftover tape with a marker. Then I started working on matching, but not pushing all the way to the edge right away. Once I had the entrance roughed in, I started focusing more on blending the rest of the pipe and trying to create a smooth transition from the oval port to the round header. I gradually moved closer to a match of the port, continuing to blend and smooth the entire pipe along the way. When I started getting close to the edges that I marked before, I mounted the flange to the cylinder, aligning them as well as I could before tightening. Then I used a scriber to mark the edges more precisely. I used coarse sanding drums to finish matching. Once it was matched up nicely, I switched to fine drums before moving to buffing and polishing bits. I didn't take the time or steps necessary for a true polish because I don't think it would make any noticeable difference in performance versus just a smooth, unpolished surface. The flange was almost complete, but I wanted to make sure that the mating surface was totally flat and smooth, so I used sandpaper on glass to hone and true the surface. If you don't already know about this process, glass is used because it's very flat and inexpensive. Sandpaper is taped to the glass, and then a part can be sanded against the glass, alternating patterns and holding methods along the way to prevent applying uneven pressure in any one spot. It's no substitute for a milling machine, but it can provide good results cheap. I started with 220 grit and worked on that for quite a while before moving to 320 and finally 400 grit. I was satisfied with that finish, but you could use even finer grits if you wanted to. The only thing left was to bolt it to the cylinder and verify that the port still matched nicely. I haven't installed everything on the scooter yet, but I did put the pieces together to see that they do fit. I can tell you for sure that this project is not something that I'd suggest to everyone. It's time consuming and there are certainly easier ways, but I'm happy with the finished product. You'll have to stay tuned if you want to see if the Stage6 RT FL100 exhaust does any better with a match flange. So make sure to subscribe and don't forget to leave a like and a comment if you've enjoyed the video or found it helpful. Thank you for watching.